Hi, Mr. Richards here. Today's lesson is on square root functions. Let's get some definitions done first, and the first is that of the square root function. It is a function that contains the square root of a variable. Next, we have the radical function, and that is a function that contains radicals with variables in the radicand. And so let's go ahead and define radicand, and that is the expression that is under the radical sign. And so we have our key concept box of square root function. The parent function of this is f of x equals square root of x. The type of graph is a curve. The domain of this parent function, at least, is x is greater than or equal to 0. The range is y is greater than or equal to 0, and you can see this on the graph. In our first example today, we have graph f of x equals 1/2 times the square root of x, and state the domain and range. Well, before we do 1/2 the square root of x, I want to take a look at a different function here. G of x equals the square root of x. I just want to look at this to see what that's going to look like on the graph before we graph the next one. Well, when I put in 0, 1, 2, 3, 4, and 5 into the square root of x, I get, well, 0, 1, 1.41, 1.73, square root of 4 is 2, square root of 5 is 2.23, and yes, you can use a calculator to help you with that. Then, now, let's look at f of x equals 1/2 times the square root of x. And so we'll look at x and f of x. And we'll still look at 0, 1, 2, 3, 4, and 5. Well, you put in 0, you get 0 times 1/2 is still 0. We saw here on the left when we put in 1, that gets 1, and half of 1 is 1/2, or 5/10. Half of the 1.41 is 0.71. And then we have 0.87, 1, and 1.12. Now, in later examples, we'll be asked to compare this parent function, the square root of x, with something like 1/2 times the square root of x, but for this example, we're just going to simply graph. And so we will have 0, 0, 1.5, 2.71, followed by 3.87, 4, 1, and 5, 1.12. And again, with these decimals, you're going to try as close as possible to graph these. But as we graph them, you can see where it's coming out like so. Now, our domain. Our domain is going to be for x when x is greater than or equal to 0. And for our range, for our f of x here, this is going to be when the f of x, or also our y, is greater than or equal to 0 as well. Let's continue on. Next we're asked, graph f of x equals negative 1/2 the square root of x. Compare to the parent graph and state the domain and range. For a lot of these examples today, we're going to write out our parent function and graph it just in order to compare it. So our parent function is, if you remember, g of x equals the square root of x. And we'll copy this down one more time here, x and g of x, and we'll have our 0, 1, 2, 3, 4, 5, and the same results as the previous example, 0, 1, 1.41, 1.73, 2, and 2.25. And next, we'll look at our f of x equals negative 1/2 times the square root of x. And so we'll have x split with f of x. And when we put in the same 0, 1, 2, 3, 4, and 5, our results here, 0, negative 1/2, negative 0.71, negative 0.866, negative 1, and negative 1.12. Now for this example, let's graph both of these. We'll graph our g of x, our parent function here, 0, 0, followed by 1, 1, followed by 2, 1.41, so just underneath 1.5 if you can. 3 is 1.73, so getting closer to 2. 4 is at 2. And 5 is at 2.25. And so here's our curve of our parent function, and that again is g of x equals the square root of x. And now we can look at our negative 1/2 square root of x. We'll start with 0, 0, then 1, negative 1/2, 2, negative 0.71, 3, negative 0.86, 4, negative 1, and 5, negative 1.12. And so this will be our curve here, and that will be for our f of x equals negative 1/2 times the square root of x. And so now as we look to compare this to the parent graph being the blue graph, what's happened? Well, it looks like we've reflected across the x-axis, and we also have a vertical compression we're also now in quadrant 4 compared to the quadrant 1 of the parent function. And as we look to compare now the domain and the range, our domain, well, this for the values of x for our red function are still going to be greater than or equal to 0. And for our range, now remember we're looking at the red function here, our f of x, our range is for f of x is going to be less than or equal to 0. In our next example, we have graph f of x equals the square root of x, then minus 1, and compare to the parent graph and state the domain and range. And so for one more time, we'll go ahead and write out our parent graph, g of x equals the square root of x. And then we have our x and our g of x here. 0, 1, 2, 3, 4, and 5. 0, 0, 1, 1, 2, 1.41, 3, 1.73, 4 is 2. Put in 5 and you get 2.23. We'll now compare that to our f of x equals the square root of x minus 1. And when we make our chart, we have x and f of x. We can use the same numbers for x, 0, 1, 2, 3, 4, and 5. And the results are negative 1, 0, 0.41, 0.73, 1, and 1.23. And when we just compare the numbers, they all look like they got smaller by, well, 1. Now, when we go to graph this, we'll start with the parent function, 0, 0, 1, 1, 2, 1.41, 3, 1.73, 4 is 2, and off here in the corner, 5 is 2.23. And so we have our curved original function. That again, for us in this example, g of x equals the square root of x. And now we get to look to compare this to the new function. F of x equals the square root of x minus 1. Well, let's graph that. 0, negative 1. 1, 0. 2.41. 3.73. 4, 1. And 5, we'll squeeze it in here, 1.23. And we draw in this curve, and that was f of x equals the square root of x minus 1. And now we can compare. Looks like we just translated it down. Every single point is 1 lower than the parent function. So the way we can write this explanation is that it's a vertical translation 1 unit down from the parent function. And now, if we go to compare our domain and ranges, our domain for our new function, it's still going to be for our x's. All the x's are greater than or equal to 0. And for our ranges, notice one of the differences here for our f of x, compared to our last example at least. It's still going to be greater than or equal to something, but it's going to be greater than or equal to negative 1. Now for this example, example 3b, I've already sketched in our table and our graph of the parent function, square root of x. In this question we're asked to graph f of x equals the square root of x plus 1, and then compare and state the domain and range as we've been doing. So now let's look at f of x equals the square root of x plus 1. And so we'll have x and f of x. And again, a calculator will be really handy here as you can just plug these numbers in. So if we start with our 0, 1, 2, 3, 4, 5 again, we put in a 0 and we end up with 1. 1 is 1.41. 2 is 1.73. 3 is 2. 4 is 2.23, and 5 is 2.44. Well, just looking from this table to this table, looks like everything was kind of bumped up here. And there's another interesting thing that we can look at. In most of our examples, we've only put in 0 and positive numbers. But what if we put in negative 1 here? Well, negative 1 plus 1 is 0. And the square root of 0 is 0. And so when we go to graph this, Let's start with the negative 1, 0. Negative 1, 0. And then 0, 1. And then 1, 1.41. 2, 1.73. 3, 2. 4, 2.23. And we'll just stop there. You could graph the 5, 2.44 as well. And as we draw in this curve, notice how everything was pretty much shifted over one spot to the left. And that's exactly how we can describe this. We have a horizontal translation, one unit left of the parent function. Basically took the parent function and moved it over one to the left here. In example 4, the speed s of a tsunami in meters per second is given by s equals 3.1 times the square root of d, where d is the depth of the ocean water in meters. Graph the function. You may use a graphing calculator. If a tsunami is traveling in water 26 meters deep, what is its speed? If you were to graph this on a graphing calculator, this is what it would look like. When we look here, we have our depth on the bottom, meters deep, and we have our speed here on our y-axis. And so if we just look at where it's 26 meters deep, it's about 15.8. Well, we could also look at saying, okay, speed equals 3.1 times the square root of d. And when we put in the 26 meters into the square root, that is about 3.1 times 5.099. So our speed is going to be about 15.8 meters per second. So you could substitute into your function and also graph your function to come up with the answers. So as we look at our last example for this lesson, graph y equals 3 times the square root of x minus 2 and compare to the parent graph. And once again, I've drawn in the parent graph of the square root of x. And so what we need to complete now is y equals 3 times the square root of x minus 2. So we can make one more xy chart. And we look at 0, 1, 2, 3, 4, and might as well look at 5 as well. When we put 0 in, 0 minus 2 is negative 2, and we can't have a negative square root right now, so that doesn't mean anything right now. Put in 1, 1 minus 2 is negative 1. That won't work either. We finally put in 2, and 2 minus 2 is 0, and the square root of 0 is 0, and 3 times 0 is, well, last time, 0, so 2 is 0. Put in 3, you get the square root of 1, which is 1 times 3 is 3. 4 minus 2 is 2, and 3 times the square root of 2 is 4.24. And then when we have the 5, it's up to 5.19. So as we complete this now, 2, 0 is actually our first point now. And then we have 3, 3, and 4, 4.24, and 5, 5.19, which is way up there. And as we connect this graph, it's something like this. And that's the graph of y equals 3 times the square root of x minus 2. And when we look for what in the world happened here, we have certainly had a vertical stretch. And we've also translated 2 units to the right when we compare it to the parent function. And last, we have our domain and range comparisons. And for our domain, all of our x's are going to be greater than or equal to 2. And for our range, all of our y values are going to be greater than or equal to 0. And that's it for this lesson on square root functions. Good luck.